We use these things every single day, but let's be honest, how many of us really know what's going on inside? So today we're going to pull back the curtain and take a look at how a computer really works from the inside out. Let's get into it.
I mean, really think about it for a second. You click your mouse, you tap on a screen, and bam, a whole universe of stuff just happens. But how does that simple physical touch turn into launching a program or sending a message across the world? Well, we're going to peel back the layers, starting from what we see and touch and go all the way down to the machine's very core.
Okay, so let's start with the stuff we all know, the parts of the computer that are totally familiar. This is our point of contact, right? It's the bridge that connects our world to that digital world whirring away inside.
You know, when you boil it all down, everything you do with a computer is one of two things: input or output. Input devices, like your keyboard or your mouse, well, that's how you tell the computer what to do. You're putting information in. And then the output devices, like your screen or your speakers, that's how the computer shows you the results. It's putting information out. It sounds simple, but this is the absolute foundation for everything else.
Now, of course, you're not just randomly inputting and outputting, right? You're doing it inside a program. We call these application software, or, apps. They're the whole reason we even bother with computers. Whether you're editing a video or just browsing the web, you're using an application that's built for that specific job.
Okay, but here's where it gets interesting. Underneath all of those apps you're running, there's this powerful, kind of invisible boss running the whole show. And that is the operating system.
And this is a really key takeaway here. Your apps, like your web browser, they don't talk directly to the physical parts of your computer. Nope. They talk to the operating system, the OS. We're talking about things like Windows or Mac OS or Linux. The OS is the master coordinator, the manager that makes sure your keyboard, your screen, and all your apps are actually working together.
That traffic controller analogy, it's perfect. It really is. Without the OS, it would just be total chaos inside your machine. It directs all the data traffic, it decides who gets to use the memory and the processor, and it makes sure that when you click Save, that signal actually makes it to your hard drive and doesn't just get lost in the noise.
All right, you ready? We're about to go deep, like really deep. We've talked about the software we see and the software that manages it all. But what about the actual physical engine doing the work? Let's pop the hood and look at the hardware. So right at the heart of it all, you've got the central processing unit, the CPU. Seriously, if the computer has a brain, this is it. And it basically does this constant three-step dance. First, the control unit grabs and figures out an instruction. Then, the arithmetic logic unit, the ALU, does all the math and the logical work. And the registers? Just think of them as tiny, lightning-fast little notepads that hold on to whatever the CPU is working on in that exact split second.
Okay, so the CPU is blazing fast, right? But it needs a workspace, a place to put all the programs and data it's using right now. That's where RAM comes in. Think of it like your desk. The more stuff you're working on, the more desk space you need. And hey, if you've ever had like 50 browser tabs open and your computer just starts crying, yeah, that's you running out of RAM. And the key thing is, it's temporary. Turn off the power and your whole desk gets wiped clean.
So if RAM is just temporary desk space, where does all your stuff actually live? Your photos, your documents, the OS itself, where is it all when the power's off? Well, that gets us into long-term storage, and this is where we've seen a huge change recently.
For the longest time, the answer was the hard disk drive, the HDD. And this thing is totally mechanical. It's kind of like a tiny, super fast, super precise record player. It has these magnetic platters that are constantly spinning and a little arm with a read-write head that zips back and forth to find your data.
But today, the new kid on the block is the solid-state drive, or SSD. And the difference? No moving parts. At all. Instead of spinning platters and moving arms, it just uses flash memory chips, kind of like a big fancy USB stick. And honestly, this is a total game changer.
So let's break it down. The big deal here is speed and just toughness. An SSD has no moving parts, so it is just so much faster. This is exactly why a new computer with an SSD boots up in just a few seconds, while an older one with a hard drive feels like it takes forever. Plus, they're way more durable because you don't have to worry about dropping it and messing up all those delicate moving parts.
Okay, so we've got the brain, we've got the workspace, we've got the filing cabinet, but how do they all talk to each other? Let's take a look at the communication lines that make the whole system tick.
But inside the machine, everything is connected by something called the system bus. Just think of it as a massive information superhighway. It's the set of wires and pathways that lets the CPU, the RAM, and the storage all send data back and forth to each other at unbelievable speeds. How fast that bus is makes a huge difference to how fast the computer feels.
And it's not just inside the box. When computers need to talk to other computers, they form a network. And these connections aren't just random. They follow specific blueprints or topologies to keep the data flowing smoothly. The star layout, where all the computers connect to one central point, is super common in most homes and offices you see today. Wow, okay, we've covered a ton of ground, but to really appreciate the insane piece of tech you have sitting on your desk or in your hand, you gotta look back at how far we've come. I mean, the journey from there to here is just mind-blowing.
You can really break down the history of computers into these 5 big jumps, these generations. First, you had these massive, room-sized monsters running on hot, unreliable vacuum tubes. Then came the transistor, and boom, everything got smaller and more reliable. After that, the integrated circuit let us cram tons of transistors onto one tiny chip. And then the big one, the microprocessor, which put the entire brain, the CPU, onto a single piece of silicon. That right there gave us the personal computer. And now we're living in the 5th generation, which is all about artificial intelligence.
And that brings us right back to today, and a really cool final thought. Every single one of those generations was powered by some revolutionary breakthrough. We're in the middle of the AI revolution right now. So what's next? What's the 6th generation going to be? Quantum computing? Computers made out of biological stuff? Something nobody's even dreamed of yet? Now that's something to think about. Thanks for tuning in.